All right, let's go through this problem. So this is problem number 1. It says if 10 liters of oxygen at STP are heated to 512 degrees Celsius. So what that means is we have some sort of a container that's got 10 liters. Now liters is a volume. So your volume 1 is going to be 10.0 liters. It says at STP. STP means standard temperature and pressure. So our T1 and P1 of our system. So we've got one system. So like if we have, let's say this is our box and we've got a whole bunch of molecules in our box. The volume is 10 liters. Standard temperature is 273 degrees Kelvin, or 273 Kelvin. You actually don't use degrees. So 273. If you forget that, that's on page 1 at the top of your reference guide. So you can look there also. Standard pressure, those are the numbers, the conversion numbers that are on the page 1 of your reference guide as well. We looked at that on slide 3 when we talked about pressure conversions. That picture is on slide 3 if you need to go look at that. But you've got to pick which unit to use. Now, if you look at the rest of the problem, it says, what will the new volume, so V2 is our question. What will the new volume be? We don't know. That's our question mark. If the gas, or of the gas, be if the pressure is also increased. Okay, so if it's increased to 1520 0 millimeters of mercury. All right, so for temperature here, it says is heated to 512 degrees Celsius, but we need to change that to Kelvin. So to do that, we have 512 degrees Celsius plus 273. Again, that equation is on page 3 of your reference guide. The conversion that you add 273 is on page 1. So page 1 at the top, it shows you that the STP, standard temperature, is 273. So that's where that number came from. To get this number, which is 785, that is, we raise the temperature to 512, add 273, and we get 785. Now, we gotta come back here because we're at STP when we start. So this is to start. We're at STP. So standard temperature is 273. Again, that's on page 1 of your reference guide. Your initial pressure is standard pressure. I waited because I wanted to see what units these would be in. So this is in millimeters of mercury. So if you go to page 1, on page 1, it tells you all of the pressure conversions. It uses the word standard pressure. So those are your conversions. It's also your standard pressure. All of those are equal. So you pick the one that's millimeters of mercury. So you're going to pick 760 millimeters of mercury for there. We have one variable here that we need to solve for. So in this problem, we need an equation that's a gas laws equation that has a volume, a temperature, and a pressure for our initial system. And then after we make the changes, we've got the same system. It's just our variables are different. And that's because we increased our temperature. We increase our temperature, then this is also going to increase. So let's look here. P1 V1 over T1 equals P2 V2 over T2. If you need to stop and look at page 3 of your reference guide, please do so. All right, let's fill in our equations here. So P1 is 760, V1 is 10, T1 is already in Kelvin, which is 273, equals P2 is 1520. We're looking for V2 over T2. Make sure you put the 785, not the 512. 512 is in Celsius, 785 is in Kelvin. So put 785, and now we just have to solve for V2. So for this one, V2 would equal 1438 liters. And there's your answer.